Okay, so to solve a quadratic inequation, we're going to factorize the quadratic equation. We're going to put it equal to 0. So we're going to solve the equation with equal 0, and then we're going to test values. We'll plot those solutions on a number line, and then we'll test values. We'll have to test 3 values, okay? The other method I'm going to show you, so that's method 1. Method 2, instead of testing values, we sketch the quadratic equation and you can see the answer straight away, all right? So method 1 is to do that, and I'm just going to put, so 2A, that will be method, actually I'll call it method A/B. 2A will be to test values in the inequality. 2B method, so method 2B, so method 2A will be to test values in the inequality, and method 2B will be to sketch the quadratic equation, and then you will read off the solution. So sketch the quadratic function, sketch the quadratic function, and read off the solution. Doesn't that one sound a lot better? You'll see how you can do that. So one method you can do, you always put it equal to 0 and find where it equals 0. In one of the methods, you'll then look at points on around those where the zeros occur, and you'll test values. The second method, you just sketch the function, and you'll be able to read off the solution. And well, when I do it, you'll be able to see. Okay. All right, the first one. So first we're going to solve this. So solve 3x squared minus 5x plus 2 is greater than or equal to 0. First we're going to solve, we're going to put the equation equal to 0 first, the quadratic equation. So we're solving the quadratic equation first, and what do we'll be able to factorize 3x, x. It has to be minus minus because it's plus 2. And the factors of, well, we can do our little crisscross, 3x and x. I think it's going to be, because they're both minus, what do you think, 2, 1? That's it. 3x minus 2x minus 1. And of course, you check it. So it's 3x squared minus 3x minus 2x plus 2. Great. So therefore, solving this, so therefore, if you solve this, x equals what? So solving this, what do we get? X is 2/3 or 1. Now, method 2A. Is to do the following. This is the method in the textbook. So first thing, you put it equal to 0, you find where the zeros occur, or like the solutions to the equal 0. We plot those on a number line. Because it's an inequality, remember, you don't just give values as your answer. It has to be x is less than this, or x lies between these two values, or x is greater than. So with this method, you've got to test these regions, 1, 2, 3. Now, I'm going to show you this once or twice, and then I'm not going to do it this way again. All right. So this is the method 2A. So method 1, sorry, both methods do this first bit. Okay. Method 2A is to put these solutions on a number line and test the different regions. So wouldn't the first region be x is less than 2/3, right? So let's try x is less than 2/3 for region 1. And just think of a value. For example, if x was 1, if x was 0, that's less than 2/3, isn't it? What would you get here? If x was 0, I would get 2. Is that greater than or equal to 0? That works. So I would go, I'm going to try x is 0. So first region is for values of x less than 2/3. I pick an easy value like x is 0. I substitute it into my inequality, right? And I get 0 minus 0 plus 2 is greater than or equal to 0. That is true. So therefore, x is less than 2/3 is one of my solutions. Region 2, I'm going to try x lies between 2/3 and 1. Actually, it should be less than or equal to, whatever. All right. Between 2/3 and 1, you can just think of something like well, remember 2/3 is 0.6 recurring. You can do 0.8, 0.9, whatever you like. You'd have to do that one in a use your calc. Anyone? What do you want to try? Try whatever you like. 0.8 or something. I don't know. 4/5, whatever. 3 times 0.8 squared minus 5 times 0.8 plus 2. I have a feeling this one's not going to work. What do you get? Negative what? All right, so 0.9, what did you get?
Negative 0.07.
And that is not true. Negative 0.07, whatever you're getting, is not, so that's not true. And the last region is x is greater than or equal to 1. Let's try x is 2. And what do we get? So we're going to try x is 2 into the original function. 2 times 4, that's 12, minus 10, plus 2. That looks true. 4 is greater than or equal to 0. That's true. This is what you're going to find. You're going to find, you know how I've got 1, 2, 3 regions? You'll see in method 2 in a minute, 2b. If the first one works, the third one will generally work for a quadratic, and the middle one won't. So we've got 2 solutions, so I can say, well, therefore, my solution is x. Now, this is greater than or equal to, so actually, I should just put these all with less than or equal to. I know I'm doubling up on the 2/3. It doesn't matter, all right? Just put them all with equal to because there's equal to here. So we're just going to go x is less than or equal to 2/3 and x is greater than or equal to 1 is my solution. That's my solution based on testing those points. Now, there is another way to do this. That's the end of the first method, right? The second method, or instead of doing all that testing, I can continue from here. So from this point, I can either go down or I can go across. I've got 2 ways. All I'd have to do for this one, have a look at the function. We sketch this parabola. Is it concave up or down? So and where are the roots or the zeros? At 2/3 and 1. Remember how we used to sketch them, year 10? It's concave up. So much easier. I mean, you've already factorized and worked out where it equals 0. So you just look at the original equation, you say, yep, it's concave up, you sketch it. So now you have to read off, where is this quadratic equation above, see, greater than or equal to 0? If these are x values, then y values are positive y values up there, negative y values down here. Does that make sense? So here we've got, above this line, my function is greater than 0. On the line, my function equals 0, and below the line, my function has y values less than 0. Does this make sense? I just read the solution off this sketch. Where is this? I need greater than or equal to 0. Isn't that all up here? Where's it above the line, basically? When I sketch this function, where is it above 0? Where would, if I did put the y-axis here, where is it above? Because I'm trying to solve this. Yeah, so I'm trying to solve this. I've sketched the function on the number line, right? Where is this function greater than the line? Yeah, so the answer is x is less than or equal to 2/3, x is greater than or equal to 1. Isn't that just so much easier than substituting? So the book does it in this exercise by substituting, but later in some later chapter, it does it by sketching, and I think we should just sketch. We will do it again both ways, but from now on, doing this second method. So you put it equal to 0, you solve, then you just sketch it and just say, is it concave up or down?
Please, what does the function mean?
Oh, we have to sketch this parabola. Look, it's definitely concave down, this parabola, isn't it? But we will do that with method 2. But we need to solve it. 6 minus 13b minus 5b squared equals 0. So first we're going to solve this first. To make that nice and easy, why don't we just swap sides instead of factorizing the negative quadratic? But later when we draw it, you don't draw the positive quadratic. Do you understand? See, when I want to solve this, once I've put it equal to 0, I can take it to the other side, do whatever I want with it. Okay, so I'm going to take everything over to the other side, or I can factorize out the negative. I don't mind. You want to just factorize out the negative? You want to take everything to the other side, but you need to be careful. If you're taking stuff to the other side, you still do have a concave down parabola. All right, so I'm going to take out the negative. Let's just be safer. So negative 5b squared, what would the plus 13b minus 6 equals 0? It's the same. I just don't want you sketching the wrong parabola later. All right. I could then take it all to the other side. Taking it to the other side just helps you solve it. You will get the same answer. So 5b and b, and the factors of, so one of them's positive, one of them's negative, because we've got -6. So what do you think? 3 and 2. I think we've got to go 3 and 2 plus 3 minus 2. Yeah. 5b minus 2b plus 3. And of course we would check it. 5b squared plus 15b minus 2b. Good, that's plus 13b minus 6. So therefore, now don't worry about the negative. So therefore 5b minus 2 is 0, or b plus 3 is 0. So what's b equal to? 2/5, because you know, and -3. So we sketch and put them on the number line. We're still going to do that other method, but this is the last time we do the other method. So using the first method that I showed you with testing values, right, you would do your first, you've got to check your 3 regions, all right? First region would be x is less than -3. Let's try x is -4, for example. Any value of x less than -3 into the original equation. No other equation, the original. So I've got 6 minus, or plus, it'll be plus 52, minus 16 times 5. Is that 80? Is that true? Did I make a mistake? 6? It is. So again, I've got the outers. Doesn't matter. All right, so I've got, well, that's true. I don't even have to work it out. I don't have to work it out. It's 58 minus 80. That's negative. It's -22. I can see it's true. Right. Then x lies between -3 and 2/3. Okay. See, my original equation is just less than. I'm not putting or equal to's here. All right. So my original equation is just less than. So I'm going to try, what would you try here? Between -3 and 2/3. 0. Nice and easy. What have you got? 6 minus 0 minus 0. 6 is less than 0. Not true. It's the outers again then. And the last region we're trying is x is greater than 2/5. Let's try x is 1. X is 1. In the original, 6 minus 13 minus 5. That's true. So therefore, x is less than -3. X is greater than 2/5. You need to look at the original question and it's less than. So your solutions can't have less than or equal to, greater than or equal to. It's just got to be less than, greater than. Now, that's using substitution. Remember, we can do the other method. So once we've got, or, I am going to do a third example now, but only using the second method, no more substituting, all right? Or from the asterisk. So I've got 2 ways to go from the asterisk. Substitution method, not recommended. Or the other method is 6 minus 13b minus 5b squared is less than 0. I know that it cuts the x-axis at 2/5 and -3. And have a look at the equation up there. Is that, if you sketch that, is it concave up or down? So concave down. And where is the function less than 0? Where is it below the line? Greater than 0 is above the line. Where does this graph lie below the line? That's what it means. X is less than -3. X is greater than 2/5. Now, if I asked, all right, we'll do one more. Solving this one. So we're going to solve 6x squared plus 11x plus 3 equals 0. You need to factorize. Not sure if that one's going to be 6 and 1. Is it 3 and 2? 3x and 2x, yeah. And I'd say it's going to be 3 and 1. Like that. Or 1 and 3. Yes? So we've got, of course, we check it. 3x plus 1, 2x plus 3 equals 0. Checking. 6x squared plus 9x plus 2x plus 3. Yep, that's great. Okay, so therefore, I can write this equals 0, or 2x plus 3 is 0. You don't want to mess these up when you do these. So aren't we really taking the 1 over? So it's -1 divided by 3, or it's -3 divided by 2. So they're your solutions for x. No more of that first method testing points. We're just going to sketch. So I'll do my little sketch over here. Oh, which one's lower? Which one's the smaller number? Negative a third or negative 1.5? Negative 1.5 is lower down on the number line than negative a third. Be careful. Is this a concave up or down parabola when you come to sketch it? It's concave up, we know, because it's positive 6x squared. So concave up. And where is this function below less? See, it equals 0 here. It's greater than 0 up there. It's less than 0 there. Where is it less than or equal to 0? Isn't it here below the line? Including these two values. Because I need to know where it's less than or equal to 0. It's greater than 0 above the line. It equals 0 on the line. And it's less than 0 below the line. So my solution is x lies between negative 3 over 2 and a third. Are we good? Just look at the original. If it's or equal to, these have to have or equal to's. If it's just greater than, you just put a less than or greater than, whatever works out. This is what you definitely do not do. You don't keep it less than or equal to 0, factorize, leave this less than or equal to 0 and solve it less than 0 and less than 0. You'll get one of them will be right, the other one will be wrong. You have to sketch it. So what I've seen so many kids do, they factorize it, but they keep this less than or equal to 0 and they say, well, that's less than 0 and that's less than 0, and they don't sketch it and they end up with wrong answers. You do not do that. Do you know what I'm trying to show you? I'm trying to say, do not do the following. Do not do this, which I'm about to show you. This is what you don't do. You don't factorize it and keep it like that and go, oh, well, 3x plus 1 is less than or equal to 0, or 2x plus 3 is less than You don't do that. Do not. No. I should actually put skull and crossbones with it. Do not do this. Not a cloud. Right? So look. See this? Can you see that's wrong? And this is x is less than... Do you see? You don't do that. No, 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 no. No. Right? You don't do that. You have to sketch it. Where is this? Look at the first line. Where is my parabola? This is how you look at it. Where is my parabola below the line if I sketch it? That's what you should see when you see a quadratic inequality. I know that's a parabola. I know parabolas look like this, or this one looks like that. Where is it cutting and where is it below the line or equal to the line? That's what you should see when you see a question like that. Not this. I'm going to factorize it and break it up into two parts. No, we don't do that. You can only break it up into two parts when it's equal to 0. So that equals 0 or this equals 0. A squared is less than or equal to 1. Remember, we solved the quadratic equation, so sometimes you've got to bring everything over to the left. All right? So first we want to solve a squared equals 1 or a squared minus 1 equals 0. Are we okay now? So you factorize. You always have to factorize. You can't solve it like that. A squared is less than... Well, we could. I could draw a squared and I could draw the line y equals 1 and solve simultaneously, but we're not going to do that. We're going to do that in chapter 5 later. So we put it equal to 1. You solve the equal to first. You bring everything over to the left. Whenever it's a quadratic, everything over to the left, factorize, then solve. Don't try and factorize, solve here. I know you could. A is plus or minus 1. We're going to get that, but I still want you sketching a parabola. Actually, and we're going to look at this in a minute. So I've got a minus 1, a plus 1 is 0. So isn't a 1 or negative 1? See this original equation, a squared is less than or equal to 1? That is the same as solving a squared minus 1 is less than or equal to 0. Do you agree? Okay, so if you're asked to solve x squared is less than or equal to 1, I can just take, minus 1. I'm not multiplying or dividing both sides by a negative. I just bring everything over to the left. That is actually what I want to solve. All right, so I've got that quadratic equation. I put it equal to 0. I've factorized it. So on my number line, I've got -1 and 1. Make sure you put them the right way around. Is it a concave up or down parabola? Got it? And I want to know where remember this is greater than 0, equals 0, less than 0. I need the less than or equal to 0 down here, including the dots. Got it? So what's my solution? A lies between -1 and including, because the equation is less than or equal to. So -1 less than or equal to A less than or equal to 1. Okay? So in any equations where everything is not already over to the left, see, next time I would skip this step here, go straight over there and then straight down to there. Got it? You don't need this A squared equals 1. Got it? Everyone? Put it equal to 0, like less than or equal to 0 first. So last one, x squared is less than 2x. I want you to rearrange it before you start. X squared minus 2x is less than 0. We don't need to turn inequality signs around. We're just picking up and taking over. We're not multiplying or dividing by -1. And then factorize this, x bracket x. Oh, so we want to solve. So what we want to solve is x squared minus 2x equals 0. Factorize out the x. Sometimes the easier ones people get stuck on. This is actually an easier one. So we get x is 0 or 2. We look at this asterisked quadratic and we say it's concave up or down. Concave. Up. Sketch it. It's less, there's a less than, so I don't want any or equal to's in my answer. And where is it? Here, greater than 0, equals 0 on the line, less than 0 below the line. So I need less than 0. So it's, no. When it's in between, you always see your x lies here. Do you know what I mean? X is between 0 and 2. Yeah. X is greater than 0, but x is less than 2. All right. Now, if, all right,